Hi all, welcome back to another lecture of DBMS. And in this lecture, we will learn about what exactly data abstraction in DBMS. Along with that, we'll also see the levels of data abstraction. Then we'll see database schema, database views, and database instances. So stay tuned for the video and let's begin with the very first topic, which is what exactly data abstraction means. So if we have already learned in OOPS concept that abstraction means hiding the complexity and exposing only the essential features to the users. So all the complex things, calculations, right, we have to hide it from the user and show them only the required things which they need to understand. It also allows users to interact with data without needing to understand the underlying details. So data abstraction allows users to interact with the actual data without even needing to understand the underlying details of how the data is stored. They just need to query for fetching or manipulating data and they will get the data by the DBMS. They don't need to understand what is the structure of database inside the system, how they are actually stored and all, right? So you can see here that client 1 searches for trains, right? So they just need to enter the source to destination address in the application interface and they will get the data of how many like such trains are available for that destinations. So DBMS will take the query from the user and it will find out from the databases inside this through tables. Second, also client 2 where the user will select the train seat and they will try to book the seats, right? So DBMS, whatever seat they are selecting and booking after payment, so DBMS in the database goes and book the seats and along with that also do the transaction activity because they got the money also, right? So according to that, they will get the transaction details, add up into the table, also in the user table because the user has already booked the seat. So it will the entry will get here in the user table along with the booking seat ID which should be marked as already taken so that no another user should book the seat again. So system retrieve the availability and creates the booking to the user. So if the seat is not available, then the user cannot book that. So this is how client 1 and 2 in both the cases are directly interacting with DBMS instead of knowing how the data are maintained and stored in the table inside the database. So that's what exactly data abstraction means. Now, levels of data abstractions are there. So basically, we abstract the data on 3 different levels. The very first is physical level, which is basically the database. So it deals with how data is physically stored. So physical level needs to understand the how data is stored in the DBMS and like database includes the storage device, file structure, data compression and indexing methods. So physical level have the knowledge about everything, how data is being stored, how data compression is being done and indexing methods. Second is logical level. So logical level is the upper level than the physical level, and in this level it actually defines the data is stored in the database and how the data exactly what data is stored and what is the relation between those databases. So logical level have the understanding of this, not what is the actual structure of database, because that understanding is only there with the physical level, not with the logical level. The third level comes is a view level which the user interacts with. So it provides user specific view of the data. So it might happen that in a tabular view the data is being stored, but when we want to see the data, we can see in an invoice form or some other form. So basically the form which we are seeing in the format, the data we are seeing in that format will be considered as a view from the view level. So it provides a user specific view of the data and allows different users to interact with the databases. So these are the 3 levels of data abstraction in DBMS. Now next topic is database schema. So what exactly schema is? Schema is basically a structure, you can say. Before designing whatever we think it can be of type or structure is called the schema. So it's a blueprint or structural design that defines data is organized, how data is stored and accessed within a database. So table in this form, you can see the table, right? So table is a fundamental structure within a database. So this is called schema. Each row in a table, so what exactly schema means? So how data is going to be look like, how entries in the data will be inserted. So here each row in a table represents a single instance of entry, right? Next is each column in a table represents an attribute entry. So here you can see customer ID, product ID and purchase date are the attributes. So let's suppose if instead of that name, age, Aadhaar number for one person, so name A, age 20, Aadhaar number something. So each row will be considered as the entry of the entity, means user, and each column, age or Aadhaar number will be considered as the attribute here, means parameter. Next is indexes are special data structure and improve the speed of data retrieval from database. So basically here we use indexes also, we use indexing. On that basis, instead of searching on the transaction ID or product ID or customer ID, indexing makes the retrieval of the data very fast, like how indexes are there in the array, right, starting from 0 index 1 2 3. So that's how indexing here help us to retrieve our data from the database and makes the user experience very fast. So that's all about this schema, basically the structure and blueprint of how data is going to look like. Next is database views. So views are something virtual representation of data, what we as a user can see it. So views are virtual tables that do not store data themselves, that does not have the actual data stored there, but it just have the values. The actual data is stored in the physical device. Views only have the way to simplify complex queries from multiple tables and present data in a specific format. So let's suppose in a physical device you have some number of databases entered there, right, for a person along with the name, age, Aadhaar number, okay. But along with that they also have some product ID. So with the person name we have some product whatever they bought, right. But when we want to view those things, on a page we can see name for every person, name for every age, what products they bought, right. But these, let's suppose, take it as an invoice example, right. So this invoice example, so it can be considered as a view. It does not actually store the data. The actual data storage is inside the physical storage, right. So that's what database views means. So let's suppose here, for example, you can see this table, right. So here we have transaction ID, customer ID, product and purchase date. Along with that we have another table, and their customer ID from this table and this table are same. So for if we want a customer ID with this, if we want a name for this customer ID, we'll go inside this table and we'll fetch out the name and the last name Rahul Khanna. So if we want according to a name what they bought, so we can retrieve the customer ID with this Rahul name and the things which they bought. So Rahul bought iPhone and iPad. So here in the view we can see Rahul bought iPhone and iPad and Priya bought Apple Watch. So basically recent order view, here we can see that it actually combined both the tables and gave us the data. But this data is not, this is only the representational data which we can see as a view format, right. It's not the actual data or the actual table. The actual table is this. So that's what a view means, which is a virtual table that do not contain exact data, but it shows the representation of the data to us. Next is database instance. So what is database instance? So whatever is there is saved in the database at a specific state or at a particular instant of time. Whatever data view we want to see, it will be considered as a database instance. So it is a specific state or a snapshot of a database at a given moment. It consists of data stored within the database at that time. So whatever data is being stored at a particular time will be considered as the database instance. So let's suppose for the example, let's try to understand. For instance number 1, we have name A and amount of money, it has 1000, okay. So at time t1, after some time they person A withdraw 200 rupees from its account. So after some time the amount will be 800. So at time t2 the database and time t1 the data are changed, right, at 2 different times, because so this is the one at time t1 and this is the data at time t2. So this is what a snapshot of data at a particular instance at a particular time is called data instance. So that was all about the whole lecture. I hope you learned. Now let's meet in another lecture. Till then, keep learning, take care of yourself and your family too.